Hey.
Hey.
Hello, world.
Hello.
We're live.
We are. And we want it, well, we want, this maybe not the exact right word. We want to talk about Ehcache transactions.
What's on the agenda?
Ehcache.
And
Stats if we have time.
and
That's a good start.
we're going to talk about Alex's thing. That's now your thing, Louis.
What was that?
The 107 stuff.
Oh, because you expected me to have a solution by now?
No,
Yeah,
I expected you to have been driven half crazy.
Oh no, I did not start yet.
Okay, that explains
I've
that.
been having fun in meetings, so no productive work. Well, mostly no productive work.
This is recorded. You can't
I know.
say that.
Well, you can't say he's having fun in them.
No,
Well, now they know he's having fun, they'll give him some more.
meetings are productive, always. Look at this.
Why else would we have them?
All right.
Right. Is
Ehcache.
Ludovic going to regale us with tales of...
Gory details no one wants to hear about. Okay, so I collected the most important features that we need to create before we can start having transactional cache. So at random, the first one I noticed is we're going to need some form of, in between quotes, stable locks or no locks. What do I mean with that? What I mean is when the transaction manager is going to run the two-phase commit process, it's going to do that on multiple threads. So you're not guaranteed that if you take a lock during the first phase, that the second phase will run on the same thread, so that you will be able to unlock that lock. Remember that? So either we have to have a mechanism to make the thread stable, or to be able to unlock in a different thread that took the lock, like for instance semaphores, or we don't use locks at all.
What lock? There isn't a lock for you to use right now.
Yes, there is. There is. Because do we really want to get tainted about the gory details of the current implementation?
Oh, well, no, hang on. You're saying at the moment there's a lock used in 2x?
Yes.
Yes. No, I'm aware of that. I'm saying there's no locks in 3. So you have to write your own, in which case they can have whatever properties you want.
Right, because we will need to be able to lock a given key during the two-phase commit. And yes, you will not be able
You're going to have to write soft locking.
Yeah, exactly. So
that's the first requirement. The second requirement is about enlistment. So we need to figure out an enlistment policy. The current one we have that I somewhat like it is very convoluted, because it's 1 Ehcache resource per cache per transaction. While if you take, for instance, a database or a JMS server, it would be 1 Ehcache resource per connection. So here we create Ehcache resources on the fly, and that works great, but it's really borderline standard. It has some side effects that we need to cope with in the code.
Okay.
yeah, but there isn't much that we can do about this, right? Correct me if I'm wrong, but it's because the spec assumes a connection to something.
It's one of the reasons. The other reason is, well, we could have a single Ehcache transaction per
Actually,
cache,
more,
for instance.
an exclusive connection to something, if my memory serves.
No, not according to the spec.
Okay.
But, for instance, we could have a single Ehcache resource per cache, but that means if a cache is participating in a transaction, it cannot participate in a different transaction concurrently.
Which very obviously isn't an option.
No.
Yeah, well, it's not great. So I suppose we have to stick with our.
The cache is a serialization point. Yeah,
That's not great.
that is
Disagreement of the
not
year.
great to say the least.
Hey, I'm trying to stay positive.
Right. Well, there is a workaround. If we do it this way, it's pretty easy, right? One key per cache. Problem solved.
Okay, then if you run the transaction, you'll have I don't know how many thousands of resources probably.
Yeah, that's what I'm saying. Yeah.
Yeah, but then it becomes the
Ooh.
transaction manager's problem.
Okay, then we'll need recovery. It's a slight bit tricky because recovery means how can I explain that clearly?
Well, one question first.
Yes.
In the 2x line, recovery is only provided if you are running clustered, right?
No.
What other topologies? Certainly not the open source stuff.
No, not the open source, but the
Enterprise diststore?
Enterprise diststore with FRS or something like that.
Yeah, because it can recover. Because it provides a high standard of durability.
Right, but I didn't know that we went. I don't remember that we actually implemented recovery in there. But if Ludwig tells me it's in there, cool.
Yes, it's been done in 5 minutes because PM said, "Oh, of course we expect that to work."
Okay. So we have that in there.
I mean,
okay.
The way they used to...
So what is it that we plan on doing? Because recovering doesn't necessarily mean that we crashed anyways, right?
Not necessarily crash, but at least aborted in an unnatural way.
Yeah, I understand that, but right, it could be due to something else. Yeah, I don't really know. I'm thinking about effectively what I was trying to figure out is what kind of a recovery mechanism do we want to provide for the standalone use case? And I'm unsure. I don't have answers, I realize. I don't know.
I mean, it would probably be too costly to build a proper, durable store. I'm not sure it would be a good idea to provide a supposedly durable store that's not.
Right, this is the thing. So in the 2x line, we know that people misuse stuff as misuse the cache as misused. Used, maybe I shouldn't say misused. Used the cache as a store. And so there was this kind of creeping feeling when we wrote the transactions that, oh, well, if they use it as a store, then maybe we should try and be an XO resource, and that means recovery and blah, blah, blah. But in 3.0, that was me not sure if I was saying 3x or 3.0, we know that's not the case. We know that we're only going to support caching use case. So recovery, as far as the cache is concerned, is... I don't know. It feels like it should be possible to implement it in a very sort of pessimistic way. And obviously the ultimately most pessimistic way would be to say, oh, well, if it's transactional, then when it comes back, we just dump the contents because...
You can't do this with recovery, right? Because the transaction manager will actually ask you, if my memory serves, for what XIDs are you think are...
Live. Right, sure you can live.
Yeah, hey, what's going on?
Yeah, in doubt is the phrase we're looking for, right?
Okay. I didn't remember. Anyways, that.
But the answer.
So
right.
You will have to answer.
But here's the thing: the cache also must have a mechanism for what the fuck it does if everything gets evicted, right? So you just lie and you just act like everything got evicted right before you were asked the question.
Or you could just evict everything after telling the transaction manager, yes, I recovered that.
Right. And so this is the thing. I'm saying now. I'm not saying we have to be that pessimistic, but I'm saying if we're going to implement recovery, what we need to remember is that the recovery we implement, the only thing we have to make sure is that if we are going to recover it and make it accessible to threads, that it must be the right thing. But if it's all in doubt, we can just throw stuff away. So we can make recovery really simple because we're not supporting a store use case anymore.
True. So if we went for the simplistic route, recovering means clearing the cache.
Yeah. And if you and we can be better than that, but we can be. You can ignore like. Anyway, you get my point. I think maybe. Where's my internet failing again?
I get your point. I'm not sure about the other two.
Yeah, I think I get it.
The thing I'm interested to know, Ludovic, is how are you planning on actually implementing this? Are you planning on writing all this stuff from scratch?
Are you nuts?
I don't know. Are you?
Valid question.
Okay, so you are planning on lifting as much as because it was reasonably well separated in 2x, right? So the plan is to try and lift, move, pat, drop, and then patch
and polish. Yes, that's my
patch
plan.
the edges, and the rough edges being the lack of locking and that kind of thing.
One question, by the way, well, how do we implement that? As a separate module, or do we wire that in core?
It's interesting, isn't it? Because
Louis, that's for you.
For me?
No, Louis.
Louis, sorry.
Me.
Sorry.
I'm getting too used to being called Louis.
If we can make that a module, that would be great.
Don't think it can be.
Because then we have the possibility of shipping. I mean, it doesn't complicate the potential shipping of an Ehcache Lite in the future.
All right. Oh yeah. And we can totally. Thank you so much. Lunch is being delivered. And we can totally. It's not necessarily to me about how we then package it. Yes, it enables that, and you can get a thing without the clustering. Yes, it's more about how you split it, right? Does that make sense? What I'm saying?
Yeah, it needs to dip in. It needs to dip in to things like persistence and stuff.
Yeah.
But it can be a separate module. It doesn't have to be part of core. But it's a module. It's not a wrapper.
Oh no, yeah, it's a module. I'm pretty sure it's going to replace stores instances. It's going to probably plug in there, right?
No, I think it can probably not be a store. I think it can probably layer itself around the cache, but it also needs to dip into some of the infrastructure. Like it will need to store stuff in persistence because it needs to be able to store data scoped alongside the caches and things.
Oh, anyways, whichever way.
But whichever way, it's going to be a module and blah blah blah.
So it's a separate module.
I think that'd be really nice because then that does allow us to do the light. You just don't ship the module.
And it forces the clear separation of concerns, right? There's no way to
test all the SPIs for all the services too to see if they actually, because it's going to push on the persistence and all that stuff. Because it's going to want to have a common abstraction to be able to talk, to be able to persist, to be able to create persistent side data structures, metadata structures for in both clustered and unclustered, which is going to be really interesting.
But it's only paving the ground for other modules to come, right?
Yes, there are other modules.
It's not like it just happens that
right.
Transactions is the first one that requires this and will prove that it actually works. But it's not the only one, so whatever comes out of that will be beneficial to other bits later.
Okay. Well, so those were the three largest requirements. Other than that, I listed a few open questions, minor improvements we could do, and stuff like that. Like, for instance, do we want to pin fault the elements that are participating in the transactions, or do we want to let them be able to expire and be evicted? And in that case, when something has changed in the transaction and then you commit, do we make the mapping reappear, or do we ignore it? It's a matter of choice here. So we just need to make the choice that makes the most sense. In Ehcache 2, we mixed absolutely everything.
But one thing that could be meaningful would be to rely on the veto mechanism that we have in place
Yes, but
now.
that would just lower the chances of an
Yes,
eviction.
veto. We made this decision, and we thought we could handle it. The veto was
I know.
not a brick wall.
But
Of
with
course.
what Ludovic says, I'm hearing that it's a possibility to not have a brick wall.
It's a possibility, yes.
I think that's what we have to do.
Okay, another question. Do we want to allow non-transactional usage of a transactional store? The reason why it
by
was allowed in
non-transactional?
2 is because I was overly strict for personal reasons.
I think for the XA one, the answer should be no. If you configure it as XA, you care about the whole two-phase commit thing to this extent, well, there you go. That's what you get. Otherwise, what are the semantics of certain things all of a sudden, right?
Could allow
Read
read-only
prepared.
access.
Well,
You could allow read only. Yeah, you could allow read only where you always read the latest
Alright.
committed thing or the prepared thing, or
and so what does a mutative operation do? Throw or like silently be ignored?
I would have to
No.
throw. It would have
Okay,
to throw.
Well, I also think it should, but then what's the use case? Well,
I
what
don't
are
know.
you enabling by
I
letting-
think here's the thing. I think that it would always be possible because the transactions layer, right, knows how it's storing things. It knows that things that are committed and there's no transactions about, they're just stored natively, and then anything that's in a prepared phase, we store the previous version, the old version, the new version, and we expose things as they should. Blah blah blah. Right? That stuff's all known, so we can go without any way of that. We can basically say no, you can't use it, and wait for the use case to turn up. When the use case turns up, we can write a wrapper around that says, well, this allows you to take an XA transactional cache and gives you read committed or whatever, some kind of read-only view with a certain set of semantics.
We had that use case in the past. It's been asked by some customers. And the reason why it's been asked is because if you force even if you just want to read access to that transactional cache, it forces you to start a transaction. So that means when you're going to do a put, your cache is going to be prepared and all that stuff to be enlisted. And that's a massive burden. So if you just want to do 3 or 4 gets, the time is going to be dominated by the enlistment in the transaction manager, like 100-fold. So that's why we had customers in the past who said, hey, can't we have a way to do some gets from the cache without enlisting?
Yeah, but I still wonder how much of that is a storage use case.
Yeah, well, like I said, we don't have to build
It's
it
a
now.
cache,
I
yeah.
don't think there's anything about the way that Ludovic's going to structure anything that's going to make it difficult even, and certainly not preclude providing some kind of non-transactional view at a later date. So let's just wait, see who turns up, see who calls out that would work. And if it looks like they got a store use case, we kick them to the curb. And if it looks like they've got something reasonable, then we contemplate it.
And the last question I had is probably the easiest. Do we want to stick to read committed?
I would say yes.
Way it
Yeah.
worked last time, right, was that the whole structure was just was basically agnostic of the isolation level implemented by the soft locks that were put in place on two-phase commit. and therefore we had the only implementation we had was a read committed one, but that we thought it would have been possible to take the same interface and implement a stronger isolation level.
Oh, strong, yes. Weaker though, you will need more than just the soft locks.
For a weaker isolation level.
For weaker?
Why?
No.
What would you expose as weaker than read committed?
Read uncommitted?
Uncommitted?
Fine, you can do that.
Yeah, that's easy. Instead of reading the old committed value, you read whatever is newest.
There. The moment you apply a mutation.
Yeah, but wait a sec. That's not the way it works.
No, because the way it works right now is that the old value is kept in the transaction context, which is only visible to the thread.
Yeah. This is why I said you'll need more. I didn't say it's impossible.
But I don't think. Okay, let me put it this way. I don't think we're going to get serious requests for read uncommitted, are we?
I don't think so. Well, from what I remember, everybody was happy with read committed plus the atomic methods. That allows you, in between quotes, to upgrade the read committed.
Put it this way, we know that for a large number of people, it's a tick box item. Read committed satisfies that. We know that we can do better and we can do worse, but we know that there's not a huge number of people knocking down the door wanting to use this. So why don't we just do what we had? We didn't have huge numbers of people complaining about it before. Let's do what we had before, which was just read committed.
Okay, so do we narrow the scope to just read committed and a whole shebang if we ever need to have another isolation level?
I would offer the read outside of a transaction.
Yeah, but
that's
I don't
a different
think,
story.
Yeah,
That's a different isolation level.
Look,
read uncommitted or read during two-phase commit without resorting to asking the transaction manager and therefore being required to have opened the transaction and have an associated time stamp that can be compared against versions and shit. Because the thing is, people who want relaxed generally want it because they want greater performance. It's not usually because they actually want access to the read uncommitted thing.
But that's also where I wonder how much, if anything, I wouldn't think that having read committed an XA with full XA resource support and whatnot, if the next thing wouldn't be the synchronization on the transaction. That would be cheaper. It would give you like this better performance and still participate, opening up for a race, but that maybe you can totally tolerate. And so I don't know, right? But I think if we go for what we're talking about now, I wouldn't be surprised if the next step is that. Anyways.
True. We will
Which has little to do with the discussion that we're having now, anyways. Right? So, and then only after that would be, all right, let's go for read uncommitted, or all the way to serializable. But to raise the bar would be cheaper than to lower it in terms of effort. And what? Yeah, and that's it. And it's not even, I think, the next thing that could be on the line. So I'm like, I think I would go for minimal effort RC and full XA resource support.
All right.
Make any sense?
Makes sense to me. Now you need to find a victim to implement all that.
All right, let's spin a wheel. We got him.
Does this wheel have 4 segments, each one marked Ludwig Orban?
No, it's actually a single segment.
Yeah, but I had to look upside down to read his name, but it's okay.
One of them says Ludwig. No, it's 2 segments. One of them says Ludwig Orban, the other one says Louis Orban.
Oh.
Who's was the next topic? Statistics, right?
Statistics, yes.
Yeah. So in the context of milestone 3, we want to nail statistics, and that means statistics at different levels, the cache level, the compatibility with GSR 107, which we offer already, but also what we want to measure at the store level and how this could be used by third party when they want to have finer view on what's happening inside the cache, and how much we want to offer, what we don't want to offer. In past discussions, we've had discussions on stuff like heat count and whether or not heat count should include side operations like a failing put if absent, a get all. And so the question is, my thinking is that we probably want to have as detailed as we can statistics and think about the way we would aggregate them in higher level statistics to make sure we have the necessary information at each layer so that the aggregation makes sense. So for example, heat count clearly should match what the get does, but for the get all, what does it do? Does it match one heat count for one get all invocation, or is it heat count is increased by the number of keys from the get all?
And then what does it all mean to atomic ops?
Yeah, exactly.
A put if absent that fails, is that a hit?
Yeah, potentially it is. But
So this is
the reason. What I'm saying.
And what is it then? Is it, well, because there is an interesting point out of sudden based on how the cache store works and how it delegates to, well, with the tiering in it, right? So it's a hit always. Since it's a mutative operation, it will go directly to the authority.
Yes.
And possibly do like invalidates on caching tiers above. That could miss or hit. That could actually hit twice. Is this correct? No, that's not correct. Well, not in case of the put if absent, at least. So i.e., if we expose too much of that, how much is it merely exposing the internals of the cache store?
Yep.
So I'm like, maybe we should have these around, but maybe they shouldn't be too exposed.
Yeah, no, I agree.
Like, it could be very interesting into figuring out why some weirdo thing behaves a certain way, but I'm not sure I want to, again, if you think about what, like, if it is for people to consume those figures and then draw a conclusion from them, they would only be able to draw conclusions based on their knowledge of and understanding of the cache store, which is not an API contract, right? It's how it is today. God knows how it'll be tomorrow, and God knows how it'll be to your deployment based on other distributions that you may be using. So at some point, I guess there is a line where all of a sudden you go beneath API contract. And when we do this, I think we should be very careful on how we expose this.
I mean, to me, there are three classes of metric. There's metrics that discuss three classes of statistical metrics. There are metrics on public API operations. Okay.
Yes. And I believe these should be as
visible to the user.
Visible to the user, but also as close as possible to the invocation you actually do. Meaning that we should not.
I counter to the JSR 107.
I don't know if it's counter, but like I don't want to have one statistics related to hits that encompasses get and get all and put if
What about-
absent that misses.
Okay, cool. Right, yeah. Well, then it's counted to 107 because 107 explicitly basically says basically what 107 says it considers statistics on a cache to be as an agglomeration of statistics on. And this is my interpretation of the spec. So obviously maybe my interpretation is skewed, but whatever. It considers statistics on a cache to be the aggregation of statistics on all the entries in the cache. And basically, there's the list of things that can happen into an entry. It can be read, i.e. got. It can be put. It can be updated, and it can be expired. In their parlance, it can't be evicted because the spec doesn't cover eviction, but you could add evicted for a cache that covers eviction. And then then there's this massive table that basically says, well, any operation you perform on a cache entry can be considered to be the result of can be decomposed into a bunch of these atomic. It's like microcode in a CPU almost, in that sense. And so then they say basically, so then that's where get count is the aggregation of all the micro-op gets across all cache entries, and that's where put if absent becoming a get comes from, because that's when a put if absent doesn't put, it gets. So that's why it's counted to 107. So yeah, so I think that there's metrics on public. Sorry.
I think on the level of collecting, I agree, we would be counter to 107. But we could have the default exposed public statistics could be these compound things, because that's the thing that kind
of you can break a micro-op. You can break down into micro-ops. If you know it's a put if absent and you know that it didn't put, whatever you want to call that outcome, then yes, you know you can break that down, and then you can say, well, the get is the sum of all these things that possibly represent get.
Yeah, and you've got we could have different namings to make it clear that this is not linked to the operation.
Yeah, sure. But before we dip into the philosophy of statistics, there's three kinds of statistics. There's statistics on public methods. Those should be accessible to the user. There's statistics on private methods, including methods on SPIs. Those need not be accessible to the user, and I would encourage that they aren't, because I think that they although it's nice and flashy to show the user lots of metrics, they cause more trouble than they solve.
And especially when they become suddenly part of your API, although you don't want it, because there are more.
So then you have this question of, well, why did this stat used to show X and now it shows Y when I upgrade it? Well, yeah, because the way it behaves changed, and you're relying on an internal detail. Why the hell are you looking at that? Oh, because it's there. Like unless you intentionally hide stuff, user's gonna use. Nobody got my pun. The third kind of statistics is the kind that we don't talk about because it's a hard thing to define. It's the actual useful ones, and they're not necessarily. They may well be composed partly of the public set and partly of the private set, unfortunately. And I think the most important set there is identifying what are the useful ones. Like, for example, I do think, although there are a lot of stats that aren't interesting, I do think like hit rates on tiers can be interesting sometimes, because it gives you useful information about how much value you're getting out of a.
I was more thinking about ratio.
What the user thinks about. That's what the user wants to know. So you're leaving him to understand the numbers. This is why I said. There are sometimes implemented. I don't know. I cannot come up, but I'm sure if I look into code, I could come up with a concrete use case, example of what I'm trying to say. But so bear with me. But you want to see the raw figures because you know how to understand them, and then you can draw a conclusion from that, right? Like, to what percentage does your heap tier help your gets? If it's like 1% of your gets, well, maybe, and it's huge, maybe you're just as good as like having no heap tier at all, right? It would just, maybe the cost of maintaining this heap tier is just as costly as not having it. Might just as well not have it, because then all of a sudden that heap becomes available for something else. So that's an example. These are the things that you want that you want to convey to the user through the figures. But in order to convey that to the user through the figures, you need to come up with the things I need to look out for when he sees those figures, and what is good and what is bad.
Mm-hmm. Yep.
So maybe a useness ratio of a cache of authority is way more useful.
Yes,
from other
yes, that's the thing. The useful metrics might be not necessarily raw private metrics or raw public metrics. They may well be derived metrics from both, or from a combination of privates, or a combination of privates and publics, or whatever.
There you go. Out of 100 gets on your cache that hits, only one comes from the heap.
Off heap. Yeah, or only one comes from the heap, or only one comes from the off heap. If you've got a cache where you've got like a terabyte of off heap and 20 meg of heap, but all your hits are being served from the heap all the time, then you might want to just say, well, scrap the thing because my hot set's so small, I don't need the off heap. It's not buying anything.
So there's maybe ways to express that without giving the raw numbers, because the raw numbers, again, when you think about cache store,
the raw numbers
here, right? You need to leak the implementation of those things in order for people to understand. I'm not saying it's necessarily a bad thing, again, right? It's just, this is the point I was trying to make at the beginning. We need to be very careful on how we expose that. So maybe you want to expose those raw figures so that the user can drill down into things, and maybe he needs to open the code to see the matching, like, in order to really understand what those figures mean. But I think instead of, maybe what I'm arguing for is providing more metrics rather than a different set. And for a particular one that we know in order to make them really useful, you need to leak implementation detail. I think those we should sort of not hide, but these shouldn't be the first ones you find when you start looking for details. Man, that was a very convoluted explanation, but the same thing I was trying at the very beginning.
But I think we agree on that.
On what?
If only I understood, I'm sure I would agree.
Well, the thing is, we agree on the principles, but somebody still has to figure out what the damn metrics are.
Exactly.
So something like the 107 set of stats, it's the kind of thing users want to see from their cache. How fast am I putting, how often is my cache hitting in general, like in our case, across tiers? Is my cache evicting a lot? Again, in general, so in our case, evicting from the authority. And I think it's pretty easy to present these. And in order to present these, we probably need to create compound statistics from the detailed statistics we will collect internally. That's one thing. And we expose, obviously, these. And then the kind of statistics we just discussed. Like, can we find a way to express whether the on-heap tier or the caching tier on itself, or the higher tier or the lower tier of the caching tier is useful? And in order to do that, what do we need? What kind of low-level stats
do we need to collect, and how do we arrange them to provide the number that would that the end user would,
for example, on a stupid, I mean, it could be 1, 2, 3. 1 means it's probably not very efficient. 2 means it's okay, and 3 means it's working great. But again, if you still need to have outside interpretation, because if your caching tier is just working great and the lower tier is not working well, then obviously it's the case Alex mentioned where maybe you don't need that lower tier. You're paying a price for nothing, for no added value.
Which is a very useful information.
I think that if we can manage to do that, I think it's best. So would that make sense that we try to go in that direction?
But they're missing bits then at the stats framework as it stands today, right?
Maybe. I don't know. I haven't looked into it for a long time, so.
Chris? compound ups, for instance.
Yeah. So
It's
Oh, whoa, 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 whoa. Don't forget that at the agent code level, because we're going to expose those stats via the agent and nothing else, remember? At the agent code
Well,
level,
I don't know that I agree with that, but
the first
that
part's
was the
definitely
latest
correct.
agreement we had.
No, the latest
that-
agreement
I
we
don't think
had
we-
was the PM would not require us to expose it in any other way. But for the interests of the OSS users, I think it's kind of important that there is some kind of a Java API to access
Yeah.
this stuff.
It looks
Like-
like we misunderstood each other back
Like,
then.
for instance, JMX.
No,
a Java.
that's not a Java API.
And you can bolt on a JMX one on top of that probably very easily. That's fine. But
Hold on a sec.
but
You
we
just
don't
said
want
you
people-
need a Java API to access those stats, but the agent is going to provide a Java API to access those stats.
Oh, maybe then it's all in there. I don't know. We'll see about that. But
Within the same JVM, you can access the agent through simple method calls. It's just that the agent is also exposed remotely for all our stuff.
well, then maybe that is that. That's fine. But okay. So what are we discussing?
So what I meant is there is some logic in place inside the agent to compound counters and existing statistics into exposing.
Right.
something
But
different.
think of a get all. Right. A get all all of a sudden results in n. A get all for n keys results in
And get.
no.
I don't know.
Right, but with different outcomes. Yeah, maybe you ask for 100 keys and you only find 70 and you have 30 misses.
Yeah.
And the
Yeah.
interesting bit is you want to still record this at the root level as a compound up that had that outcome. Because when you want to,
Okay,
for
that's
instance,
weird.
the latency, the latency only becomes, like certainly in a clustered use case, only becomes interesting when you can actually compare apple to apple, right? And obviously, a get me 1,000 keys that results nothing ever is going to be faster than a get me 1,000 keys that returns like blobs of XML.
I think. I mean, yeah. What Alex and I talked about was this idea that we wanted to have the primary, and I don't necessarily mean the first choice, but the initial representation of the stats is what Louis described. It's the statistics on the actual operations. You do a put if absent, you do a get, you do a bulk get, whatever. And so that's the initial view. But a statistic might have multiple ways of being decomposed. And the two we thought of initially, the first one would be any statistic can be composed into micro-ops, which is JSR 107's view of the world. I.e., for example, right now, the way that the 107 stats, I think this is still true in the 107 layer for Ehcache 3, aggregates its gets is there's this little bit of code that says, here's all the things from the table that result in a get. So let's go and find all the things, and it says put if absent dot miss plus this plus that plus this plus that. Right? That's nice, but it's the wrong place for that knowledge to be. It's wrong that the knowledge about how basically our version of that table is encoded in some piece of procedural code inside the 107 wrapper. So what would be nice would be you to take any operation and say, please break this thing down into micro-ops for me. Now, quite what the API looks like in Java, I don't know yet, but something like that. The other kind of breakdown that's interesting is if you have an operation that can be broken down into an equivalent set of logical operations, i.e. a bulk operation. So a bulk get, we know it's logically equivalent, or bulk get all rather, whatever you want to call it.
Yeah,
it's
but
logically equivalent to a bunch of gets.
But it's not true. If you want to monitor this, and what you care about is say how well, and I understand this doesn't entirely apply, but bear with me. If the thing you wanna monitor is how well you grouped your things according to data locality on systems.
Right. Oh yeah,
I need to know that a batch of 100.
Right. There might be additional breakdowns too. I'm saying it can be logically broken down into a sequence of gets because they have the same effect.
Yeah, you can.
There
but
are
you need to keep
you're
this-
now describing a third possible set of breakdown, which is that a bulk get might have been decomposed internally and run as a sequence of gets. That's not a logical breakdown. That's a physical breakdown. It was actually broken down in this way, so you might want to be able to get access to that.
What I mean to say is certain operations leak all the way down through the stores, potentially beyond VM, right, to be compound ones. I don't think we should treat these as nth gets with nth different results, but we should record the fact that they happened as a batch of n.
I agree with
Right.
That's all I'm trying to say.
Yeah.
Cool.
So it sounds like that there's maybe three kinds of breakdown that an operation could be viewed as a set of micro-ops. It could be viewed as a logically equivalent sequence of operations, and it can also be viewed in terms of its internal structure, effectively broken down physically. Because we talked about this, you might want to say this get took 100 millis. Well, what fraction of that was querying the heap and missing, and what fraction of it was querying the off heap and missing, and what fraction of it was querying the cluster? And when you query the cluster, how much of that time was spent preparing the message, how much of this time was spent waiting for sending the message, and how much of the time was spent waiting for a response, and so on. And maybe the server sends information back as well about how long it took it to query things. So then you can look at network. Like, I'm not suggesting that we do this all the time, but these are all things that I think are interesting. But again, it comes back to what are the interesting metrics? And it's like an 80-20 rule to play here, isn't it, obviously?
Yeah, but I was thinking in the context of the 80% rule. What you just described for me, the last example you took,
That's the last
feels-
20%.
Yeah,
feels
that's
like
Takes
20%.
80%
Yeah.
yeah.
It's not what the average user wants to see.
No, I think
For developer.
I think
view.
what Alex talks about is interesting, and I think it's something that we want to look at in the future. But I think for 5.0, we know that.
No, wait. What Alex was mentioning, for me, is a valid concern, and is something that, if we can bake in from the get-go, would be great.
Right, we're talking
Which
about a
is-
physical decomposition of operation into subcomponents.
Exactly. So
But that's the same thing I just described. All we're arguing about is at what depth, how deep do you go?
I think it was where you stopped, the depth at which you stopped. I think they were both telling you that this is probably below the 20% bar.
Oh yeah, but again, but then we're pushing out the hard decision, which is where is the 80% bar or the 70% bar, whatever bar you want to
Apparently
get.
above you and below Mike.
Above me and
Somewhere
below the ceiling.
there.
It's between the floor and the ceiling, but we don't know where.
Looks like it's between Canada and West Virginia somewhere. It's in between there. If
I
drive
can
down
push
to
that
DC
ceiling to Maryland, actually.
If I drive down to DC, I'll pick it up on the way.
Way, fair enough.
Okay. Well, I don't think we'll make a decision on where.
No, we're not going to make a decision
No,
right now.
others. But if we split from a high level perspective, right? Again, those logical operations that people do on a cache and move our way down from there. I think per
Yeah.
ops, that is. And
But this-
obviously there will be sort of overlap at
Yeah.
one point, right?
But this feels very much like a replay of a discussion that you and I had, Alex, when we talked about bulk stats.
Well, you know, it's a problem with us, Chris. We just talk, we never do
That's
anything, and we repeat ourselves all the time. We're pretty pathetic.
Yeah. As long as nobody else thinks we're pathetic, we're okay.
Well, we won't tell them.
No,
That's the secret.
I'll not say anything.
No,
and I
you
certainly
say
won't
the
listen.
Anyways, even if you would tell them, they will not listen, as usual. That's why nothing makes progress.
So I guess, but in terms of the APIs and stuff, and be able to do the breakdowns and these kind of breakdowns, that stuff can all be spec'd. Then the whole question of how.
But so what? The first step would be to go over that table in GSR 107. Go over
No.
the operations.
The first step is to define what the API looks like for how you do these how you say, I've got put if absence. Please break it down into the possible set of micro-ops, and then it will say, oh, well, put if absent operation, that breaks down into gets and puts. So here's the gets that will go caused by the put if absence, and here are the puts. And I'm guessing that the get and the put don't expose latency, because they may not have a physical basis. You can't tease them apart. They're not that simple. This is the difference between a logical breakdown and a physical breakdown. But they will have rates, and they'll have counts, and that kind of thing. And then you probably need to have some API for doing aggregating operations, because then the expression, the thing you want to express when you're returning JS 107's get count is get me all the operations, break them all down, give me all the ones that give me a get. Then aggregate all of those together, and then return the sum of the aggregation of all of them. That's the get count. And then it's totally flexible to you adding a new operation that performs a new get.
And for you, that's what? A statistic framework responsibility, or is...
Assuming that we think that this kind of breakdown is something that's valid beyond Ehcache, then yes. Which I think it probably is.
I think so too.
So it's Anthony's responsibility?
No,
Not sure who's officially owning that thing now.
no one.
Sweet, it's nobody's responsibility.
All right, let's push all the work down there then. What else can we put
let's
there?
go to the other Chris then.
Yeah, XA transaction in there too. It's like the statistics framework's business.
It's going to have stats.
Sweet.
Okay, but then I'll start having a look at that. I'll probably ping.
Yeah, but I think it's to start with the API.
Yeah, but that in that case it's a statistics API.
Yeah.
So you have to be able to create relationship between statistics results and something else.
Multiple somethings else.
Multiple.
It's a decomposition in multiple that can be done in multiple dimensions.
No, but so for example, you've got statistics outcome and something else, and the one outcome is one something else. Like put if absent miss means get. But the problem is...
Well, no, but the thing now you're oversimplifying because the arbitrary outcome of an operation could be multiple micro-ops.
Yeah,
what
true.
I was considering is that you have an object that represents the put if absence on a cache, and you can say, "Give me the logical breakdown," and it gives you a set of objects where one represents the gets caused by the put if absence, one represents the puts caused by the put if absence. And then you can ask how many gets were there, how many puts were there, what's the rate of gets, what's the rate of puts.
Logical gets.
Logical gets, yes. Not, i.e., whether or not it actually ends up doing a get on a map or what is arbitrary. They're logical, i.e., it extracts a value from the cache and returns it to the user. So it was logically a get. I don't know. But hey, do what you want.
Okay, but that means, okay, I'll go down in the stats framework and see what can be done there.
And then there is another question, because what I described is a breakdown at a higher level where you haven't, but there is the question of, are you interested in breakdowns at the event by event level? I.e., if I end up with, because what I'm saying, right, is that you've got the set of all events that occurred, and I'm saying you can break this into the set of all gets and the set of all puts, right? But how do you know if one operation ended up resolved? How do you know? So suppose that you say there were 1 million put if absence, right? And then I break it down, and it says, well, there were 750,000 gets and 250,000 puts. You don't know if some operations resulted in gets, some operations resulted in puts, or some operations resulted in a get and a put, and some operations resulted in nothing. Because you don't know how the things correlate.
Is that important when we do the logical decomposition?
Not from as far as 107 is concerned, but I don't know as far as a user is concerned. It might be. They might want to be able to say what fraction of operations resulted in a get and a put. Not that a put if absent can do that, but it's a hypothetical. I don't know. I'm kind of being annoying and just throwing things in the air and seeing what happens. It's because I don't know any better. Really.
What I'm more interested on that level is exactly what kind of information we need to record when we do a compound operation. Because it's not just the outcome.
It is just the outcome.
Why you want to have one get all outcome, but you want also to link that
Oh, well, that's a specialty kind of decomposition, though, isn't it?
to
That's
the
something the
fact
stats
that,
framework can't even handle yet.
well, the other one doesn't have.
Bulk stuff. Well, no, but the thing is that what I described. So the API originally described where you have this thing that represents all the operations, and you can ask for the rates, and you can ask for counts, you can ask for latencies. You can have a method on that says, please break it down into micro-ops, and it gives you the micro-op breakdown. But like I said, that's broken any knowledge about the correlations. The other thing you could do, but the other thing is, but you do know that every result, every outcome of that operation type can be mapped to a set of micro-ops, and you presume that every possible logical combination of the universe of micro-ops has a unique representation in the outcome of that event. Otherwise, maybe we need to rework on what the outcomes are. So then maybe the answer is, if you want to know what happens in a put and get, well then figure out what that corresponds to in the result of the big operation, and then because you can already do that breakdown, you can already take a put if absent and say, I want to just see a statistic that represents the puts, the result, I don't know what the word is in the outcome language, but put if absent that puts, and it will give you an object that represents that. And you can ask, what's the rate of these? And so if you broke that down, then maybe you'd know something. I don't know. I'm kind of. I still feel like one of the reasons we're floundering here is we now know what framework we want, broadly speaking, but we don't have a clue that we don't have any idea of the details because we don't have any idea of the requirements or the use cases.
We just discussed these.
We discussed the generalities of them. We didn't discuss the specifics.
No, true, but yeah, let's aim for some specifics that make sense, and we build them up.
Okay.
And we believe the framework we have underneath gives us the flexibility to build something else should it be needed.
Yeah, sure. I mean, let's bash at it and see what comes out. I think that what we talked about makes sense. I don't know if it covers everything, but I don't know if the things it doesn't cover are actually important things.
The one thing I'm wondering is about linking statistics records in the context. So you're at the cache level. You've just started a statistics for a high-level operation.
Right.
And you potentially want to navigate from that one to all the statistics that were collected on the same thread between the begin and the end.
That seems
right, that's where the correlation is really interesting.
Seems going a bit too far to me. It would be nice, but it looks like part of the 20% that takes 80% of the work.
I don't know. For example, the decomposition of so if we go clustered, the decomposition of the get all into multiple get alls, each to a stripe, could be interesting. I agree that the decomposition of the latency of a get into the latency at the different store levels, that's probably going too far.
You might be able to do that at a different level, like say you have a get all doing 90 keys and it gets 30 on all 3 stripes that are present in your TSA. If you look at the cache statistics, you will see, one get all of 90 keys. All 90 succeeded, great. But then you can go and have a look at the statistics of each stripe.
Yeah.
And see, hey, I got a get all of 30. And all 3 of them, you will see, I got a get all of 30.
The other thing I worry is that the more information you try and extract here, the more it starts to look like you're just writing a profiler focused on a cache.
True.
Yeah, maybe that's too much. Well, I don't know. We already close to have a dependency injection mechanism at the service level. So maybe we just need a profiler. And then we had then we had a coffee machine, and clearly.
And light bulbs with IP addresses.
Instead of things.
That's the thing of the past.
Yeah.
Get bored with IP addresses. Are you living in 2014?
As long as they're IPv6 addresses.
Exactly.
Otherwise, there's a real
Wouldn't
significant limit.
want to
on
run
lights
out
in
of
the house.
them.
No, shit! I can't have more lights in my house. Got no more IPv4 addresses. Oh,
All right.
Right.
Okay, thanks. So I'll first suffer on the issue with regards to the state and the GSR 107 wrappers, and then I'll go on that
and suffer
statistic
on this
stuff.
one too.
Yeah.
Sweet.